students. Good morning, all of you. Once again, a warm welcome to the mobile computing online session. Today, lecture number 3 in unit number 4. We are successfully entering into the unit number 4. In the past two lectures, we covered the topics in unit number 4, that is TCP and what is standard TCP techniques, where TCP is used, and what are the drawbacks of classical TCP in mobile communication technology. So how we have to overcome those drawbacks. So that what we discussed in the last session. Yeah, before as usual, before going to start the session, just we recall what happened there in the past sessions. This is the session number 1. Here we discussed about the traditional TCP, with the TCP/IP model, 5-layer model, congestion control, slow start, is the threshold, congestion avoidance, congestion window size, is the congestion diagram, and fast retransmission and fast recovery. Packet is lost when in data transmission. So how we have to we get back the packets as quicker as possible. This fast recovery and retransmit. These are some problems with the traditional TCP in wireless environment. So TCP is very much suitable for wired environment, but there is some drawbacks are there for wireless environment. So these are the problems with the traditional TCP. To overcome this, here in the lecture number 2, we covered some topic. Those are classical TCP improvements. Classical TCP improvements. So indirect TCP, snooping TCP, mobile TCP, all of the classical TCP improvement techniques. So that's what we discussed in the last session. What happened there in indirect TCP? Some part is wired communication network, and some part is wireless TCP. Here the fixed host, access point, and mobile host. Fixed host sends data packet to access point. Thereafter, access point sends that particular data packet to mobile host. If any data losses happen, again we want data packet from fixed host. That is a some much disadvantage here in the indirect TCP. So to avoid that, so a technique of snooping TCP is implemented. Here a snooping buffer is there. Whenever packet is reached from fixed host to the access point, there a copy of the packet is available. So whenever it transmits packet to the mobile host, if packet is lost, no need to move to the fixed host. Access point sends that particular copy to the mobile host. That's what we discussed here in this diagram. So correspondent node, that is a fixed host, mobile node, mobile host. Fixed host wants to transmit packet to mobile node, correspondent node to mobile node, packet transmitted and acknowledgement received. In case if any failure in the packet delivery, then no need to go here. Here the fixed access point transmits the data packet. So that's what we discussed in the last session. Advantages and disadvantages of snooping TCP and mobile TCP. It has the approaches as the same goals of ITCP and snooping TCP, and to prevent the sender window from taking if bit errors or disconnection, but not congestion cause current problems. That's what we discussed. So how it helpful for wireless communication. So advantages of mobile TCP, disadvantages of mobile TCP, all we have to be covered in the last session. Now here in the lecture number 3, so the first topic is transmission and timeout freezing. Transmission and timeout freezing. Often MAC layer notices connection problems even before the connection is actually interpreted from a TCP point of view, and also know the real reasons for the interruption. So it doesn't know exactly why the interruption is occurred, why the packet is lost. The MAC layer can inform the TCP layer of an upcoming loss of connection, or that the current interpretation is not caused by the congestion. TCP can now stop sending and freezes the current state of if it's a congestion window and further timers. The MAC layer notices the upcoming interpretation and early enough both the mobile and the correspondent host can be informed. So where it has to be informed, it has to be informed at the MAC layer. It notices the upcoming interruption. So with a fast interruption of the wireless link, the additional mechanism in the access point are needed to inform the correspondent host of the reason for interruption, and otherwise the correspondent host goes into slow start and assuming congestion and finally break the connection. Here, as soon as the MAC layer detects connectivity again, it signals TCP that it can resume operation at exactly the same point where it had been forced to stop. For TCP, time supply does not advance, so not time expires. That's what happened here in the transmission timeout freezing. So exact transmission and where the timeout freezing is happened, but these are the advantages. If offers a way to resume TCP connections even after long time interruptions of the connection. But disadvantage is lots of changes have to made in the software of mobile host and correspondent host and foreign agent that is access point. Lot of changes. Waits for long amount of time. That is advantage. But it made softwares. It changes. Lots of changes have been made in software of mobile node, correspondent node, and foreign agent. That is the disadvantage. Can be used together with encrypted data as it is independent of other TCP mechanisms such as sequence number or acknowledgements. The what transmission and timeout freezing. So the MAC layer notices connection problems even before the connection is actually interrupted from the TCP point of view. So where it is interrupted, that is in the point of TCP, and also knows the real reason for the interruption. The MAC layer can inform the TCP layer of the upcoming loss where the data is lost of connection, or that the current interruption is not caused by congestion, that is transmission and timeout freezing. And the next one is a selective retransmitting. So it cannot send again and again the same packets. It sends only the selective packets, that is called selective retransmission. If packet losses happen, it doesn't send same packets again and again. Which packet is lost, it identifies first that particular packet, then starts the resending of that particular packet. A very useful extension of TCP is the use of selective retransmission. The TCP acknowledgements are cumulative, that is, they acknowledge in order receipt of packets up to a certain packet. A single acknowledgement confirms the reception of all packets up to a certain packet. If a single packet is lost, the sender has to retransmit everything starting from the lost packet, go back and end retransmission. If a single packet is lost, no need to send again and again all the packets. This obviously wastes bandwidth, not just in the case of a mobile network, but for any network. If one packet loss, if you have to retransmit again and again all the packets, then it wastes the entire bandwidth, either in mobile network or in any networks. So in the selective retransmission, using selective retransmission, TCP can indirectly request a selective retransmission of packets. The receiver can acknowledge single packets, not only trains of in sequence packets. The sender can now determine preciously which packet is needed and can retransmit it. So the main advantage of this approach is obvious. A sender retransmit only the lost packet. This lower bandwidth requirements and is extremely helpful in slow wireless links. And the disadvantage in that a more complex software on the receiver side is needed. So also more buffer space is needed to resequence data and to wait for gaps to be filled. So that is selective retransmission. And the last one is a transaction oriented TCP. So assume an application running on the mobile host that sends a short request to a server from time to time, which responds with a short message, and it requires a reliable TCP transport of the packets. For it to use normal TCP, it is inefficient because of the overhead involved. The standard TCP is made up of three phases: setup, data, transfer, and release, which is called it as a three-way handshake. If sender wants to communicating with receiver, first sender sends a request. If the receiver accepts it, he sends an acknowledgement. Then only sender starts transmitting of data packets. First, TCP uses a three-way handshake to establish the connection. At least one additional packet is usually needed for transmission of the request and requires three more packets to close the connection via a three-way handshake. So for sending one data packet, TCP may need seven packets altogether. This kind of overhead is acceptable for long sessions in fixed network, but is quite inefficient for short messages or sessions in wireless networks. This leads to the development of transaction-oriented TCP, that is called TTCP, and TTCP can combine packets for connection establishment and connection release with user data packets. This one, three-way handshake, mobile node correspondent. If you want to communicate, first sends a request. If it is accepted, acknowledgement, then sends the data message, acknowledgement. So here the connection setup, for setting up connection, it sends request. After the connection establishment, it sends data, then it sends release request. First sends request for connection, acknowledgement is back, then it establishes a connection. After establish the connection, it sends data. So thereafter it receives acknowledgement. If the task is completed, it sends a release request. Connection release request is the simply three-way handshake technique. So for request of data, acknowledgement sends data. After that, it releases. So this can reduce the number of packets down to 2 instead of 7. This can reduce the number of packets down to 2 instead of 7. The obvious advantage for certain applications is the reduction in the overhead which standard TCP has for connection setup and connection release. But the disadvantage is that it requires changes in the software in mobile host and all correspondent hosts. So this solution does not hide mobility anymore. Also, traditional TCP, transactional TCP exhibits several security problems. So this is the classical enhancement of TCP for mobility comparison. So what happened there? Classical enhancements of TCP, because the classical TCP is not suitable for the wireless communication technology. It will be 100% suitable for wired communication technology. It doesn't suitable for the wireless communication technology. In that purpose, we are improved some techniques. We are used some improved techniques in classical TCP. Those techniques or those approaches are this: indirect TCP, snooping TCP, mobile TCP, fast recovery and retransmission, transmission and timeout freezing, selective retransmission, and transaction-oriented TCP. These are the very most important one. So in the part 1 of unit number 4, transaction layer, transport layer, the mobile transport layer, the part 1. So how the TCP works. TCP is good for wired communication technology, but here in the wireless communication technology, some improvement techniques were preferred and used here in the TCP. Those are first one, indirect TCP. So the mechanism splits TCP connection into two connections. That's what we discussed in the diagram. So one is wired, the second one is wireless. So fixed host to access point, that is wired communication. From access point to mobile node, that is wireless communication. It splits TCP connection into two connections. Advantages are isolation of wireless link, and it is very much simple. The disadvantage is losses of TCP semantics, higher latency at handover. These are the disadvantages. And the second one is snooping TCP. So what happened there in snooping TCP? It snoops data and acknowledgement, come a local retransmission. Is the a snooping buffer is there in the snooping TCP. So the advantage is transparent for end-to-end connection, MAC integration possible, and disadvantages are problematic with encryption and bad isolation of wires link. That's what we discussed in the snooping TCP. The disadvantages: problematic with encryption and isolation of wireless links. Coming to the mobile TCP, it splits TCP connection but chokes sender via window size depending upon the window size. And the advantage for the mobile TCP is maintains end-to-end semantic handles, end-to-end semantic handles, long-term and end-to-end semantic handles long-term and frequent disconnections. The disadvantage is bad isolation of wireless link processing overhead due to bandwidth management. And coming to the fast retransmission and fast recovery, it avoids a slow start after roaming. And advantage is simple and efficient, and disadvantage is mixed layers, not transparent. And coming to the timeout freezing, here it freezes TCP state at disconnect and resumes after reconnection. It freezes the TCP state and resumes after reconnection. And advantage is independent of content on encryption and works for longer interrupts, and changes in TCP required MAC dependent. That is the disadvantage. And coming to the selective retransmission, retransmit only lost data, retransmit only lost data. Example, very efficient. But disadvantage, slightly more complex receiver software and more buffer needed. And coming to the last one, transaction oriented TCP, it combined connection setup, release and data transmission. So advantage efficient, but disadvantage it changes in TCP required, not transparent. So this is about the comparison of all the approaches of classical TCP enhancements. Once again, I'm repeating the approaches are indirect TCP, snooping TCP, mobile TCP, fast recovery and retransmission, transmission timeout freezing, selective retransmission, and transaction-oriented TCP. Just we have to observe only the mechanisms. So indirect TCP splits the TCP connection into two connections. Snooping TCP snoops data and acknowledgement local retransmission. So buffer is arranged here in the snooping TCP. In mobile TCP, splits TCP connections but chokes sender via window size depending upon the window size. In fast recovery and retransmission, it avoids slow start after roaming. And timeout freezing, it freezes the TCP in the current situation, in the current state, freezes TCP state at disconnected and resumes after reconnection. The selective retransmission, it retransmits only selected bits, selected packets, retransmits only lost data. And if packet 6 is lost, it just retransmit only packet 6. No need to transmit again from packet 1 onwards. That is selective retransmission. Coming to the transaction oriented TCP, it combined connection setup, release and data transmission. Okay, that's it for the part number 1 of unit number 4. So transport layer protocol. The main agenda of transport layer protocol is, what are the transport layer protocols? The basic transport layer protocol is TCP. So is TCP is preferred for wireless networks? TCP is good because there is no data loss in the, if you have to be using TCP protocol. But it is not suitable for the wireless communication. For that purpose, some improvements are required. What are the improvements? So the classical enhancements to TCP are the improvement techniques. These are the different approaches of TCP: indirect TCP, snooping TCP, mobile TCP, fast retransmission and recovery, timeout freezing, selective retransmission, and transaction-oriented TCP. So all these are we covered in the part 1 of unit number 4. So if you are good in this table, good with this table, mostly you attempt one short answer and one essay question. There is a possibility of 2 questions from this unit, either 5A and 5B. In that A question is came from these 7 concepts. So if you are good in this table, some more diagrams are there. That what we discussed in the last session. So if you go thoroughly with this table, then you can easily answer part 1 of unit 4. Okay, we will be back in next lecture. Slightly go into the part 2 of unit number 4. So just we recall what we covered in this session is So transmission timeout freezing, selective retransmission, transaction oriented TCP. Okay, in overall, first part consisting of first part of unit number 1 consisting of introduction to traditional TCP, where the traditional TCP is used, and what are the so what happened when traditional TCP uses slow start, fast recovery? When what happened there in the packet loss? So what are the basic problems of traditional TCP, and what are the classical TCP improvement techniques? Indirect TCP, snooping TCP, mobile TCP, and along with TTCP, ITCP, STCP, and MTCP, there's some other techniques called transaction and transmission and timeout freezing, selective retransmission, and transaction oriented TCP. So another techniques are there. So these are the classical improvements of traditional TCP. Okay, that's it for today's session.